guys, today is the day 15 of the 28 days data science AI Gen AI challenge what we have started. So today I'm going to talk about a CNN code which I'm going to implement. But before I go ahead, let me try to do a very quick recap on what I have explained you yesterday about the CNN. Okay, so first, if you think about image, right, let's say for example you might have seen in SHIEN, you might have seen in Amazon, when you upload any kind of image, it detects whether what kind of category it is. Is it a shoe, is it a dress, is it some kind of sportswear? So how does it do that? So we'll try to look into it with the help of a CNN model. So it's me again, Mahesh, having 14 years of experience in data as a data architect, data engineer, data scientist, data trainer. Okay, and I'll go ahead and try to explain the concept of CNN. So I'm going to take an example of data called Fashion MNIST. Let me explain what is this data about. So this data has somewhere around 70,000 grayscale images about different kind of product. Okay, and in this product there are t-shirts, there are trousers, there are dress, there are shoes, different kind of stuff. So everything has a label. For example, t-shirt can have a label of 0, trouser can have a label of 1. As we go ahead, I have different kind of label. The labels I'm going to show you in the code directly. Okay, so why MNIST? MNIST is a very good way to start the concept of CNN because it is a very good data set, consists of different kind of images, and that too very important in a grayscale. Okay, so because it's in grayscale, the image size is very small, so it becomes very easy for our model to compute also. It's a good start to do with the help of MNIST data. Okay, very quick recap. So CNN architecture consists of a convolution layer where it has some kind of filter, where it uses that filter to extract the important features. It has a pooling layer, so basically whatever feature we have extracted, trying to get the maximum or important features from that, right? Then using a fully connected layer which is very similar to ANN. Okay, I have put forward a concept here in the diagram also. Data processing. So what I'm going to do one level of data processing. So basically the data what I have is between 0, the pixel data is between 0 to 256. So I'm going to make sure that the data comes between 0 to 1 range. I'm going to show you the example also with the help of what kind of calculation I'm doing in the code side. And the splitting, the train test split, which we know is simple one, which I don't have to explain that. If you have any question, please see in my previous videos. I will put in a description also. Now, after we understand this, we have to just do the same concept of building the layer, right? Building the layer first, compiling and then setting the optimizer and evaluating the code. How is it, the operation, how is it happening? So I have done that thing in my code. I put forward the results here. So in terms of training and accuracy, you can see there's not much difference. Okay, the difference is between 90 to 94. I will say it's a good fit model in that sense. If +5 is my threshold difference, if you see the accuracy is also reducing. So in short, it is a good model. Okay, and if you have any questions, put forward those questions in the comment. I will try to explain those. I'll give my feedback on that. So conclusion, I will just put forward, take this code, the code which I'm going to explain in the next set. Take this code, try to do it at your own end, and try to come up with any kind of questions if you have. If you have any kind of questions, put forward those questions. I'll try to reply you. It's not only in YouTube. I've also started a Discord server. You can find the LinkedIn link in the code. So please forward and please answer, and please put forward your comment into the comment box. I'm happy to answer. Okay, see you in the code part of it. So this is day 15. I have explained the CNN code here. So as I have done the last times, I have put forward the code in different cell. I put forward the title, what's happening in that cell. Again, the first line talks about the Discord server link, where I have created a Discord server link where anybody who would like to ask me any kind of question, they can join me in the Discord server. You can put forward the questions there itself. I have recently got one feedback from there. I'm happy to get more feedbacks too. Okay. The GitHub link is here, the LinkedIn link is here, so that there are multiple spaces where you can come forward and ask me questions. Okay, so the first cell talks about the important libraries which are going to be required to solve the CNN code. Before you do that, always remember, when you're running the CNN code, always go ahead and change the runtime type to GPU. Okay, the reason behind that, if you want to know, let me know. I'll put forward the answer in the comments. Now go ahead and bring the data, the Fashion MNIST data. So here I've spoke about the extraction of the data and the data transformation which is been done upon it. If you remember in the slide part, I have shared that I'm going to do a transformation which will bring the data between 0 to 1. So data is between right now is between 0 to 255. Okay, sometimes it becomes very complex for a model to understand between 0 to 255. So I have made it simpler for the model to understand between 0 to 1. Okay, so to do that I have done a division of whatever the data is divided by 255. Then I'm going to get a number between 0 to 1. I'm going to show you the answer also. So basically this is what I have done for the first image. The first image shape is between 28 shape is 28 by 28. Technically talk about the pixel which we have 28 by 28, right? With 1 is the grayscale. So this is the data what we have. It is technically in a array format. Okay, so if you see here, you won't be able to understand what's exactly is happening. So what I have done, I have plotted that this image into a grayscale with the help of matplotlib, right? So take 2 seconds, pause this video and see what does it looks like. Okay, so what are the options I have? I have t-shirt, trousers, pullover, dress coat, sandals, shirts, sneakers, and bag and ankle boot. Okay, so what does it looks like? So as per the label, it looks like 9, which is ankle boot, which is technically, even I feel it looks like an ankle boot. Okay, so it means that the data looks nice, data looks proper. So what I have done here is that I have built the SHIEN architecture. The SHIEN architecture consists of three modes, right? The convolution base, the pooling layer, and the fully connected layer, right? So the convolution, this is the part of the convolution base where it consists of pooling layer 2. So I have, if you see, there are filters / kernels. 3x3 filters is here, 3x3 filter is here. So combination of it is going to help us to make the image, extract the features of the image more properly, and then I pass that extract feature to the fully connected layer, which is nothing but the ANN kind of layer. Okay, so if you understand this, it's good. If you don't understand, put forward in the comment. I'll help you to explain, elaborate the whole idea and try to explain what is happening here. Here it's something similar to what we have done in the ANN also. We have put forward what is our optimizer, the item optimizer. If you don't understand what is item optimizer, I've explained in my previous videos. I'll put forward the link in the description. Okay, so the matrix which I'm going to put forward, going to have a look on, is accuracy. I've trained the model. I've kept my epoch as 10. The reason behind that is that because 10 gives me a very good value. If my baseline is somewhere around 90%, I've got my baseline of 90% accuracy within the 10 epoch itself. Here I have put forward my accuracy, which is somewhere on 0.91. If I put forward the thing into a visualized manner, so this is the visualized manner. So from between 0 to 10, if you see, every epoch has improved my accuracy. And if you see, the last accuracy what I have got for training and validation is somewhere between 94 and 90, which is less than minus 5%. So I will say that this model is a good fit model, and it goes for the accuracy for the loss also. Across the board, the loss has improved as I go ahead. Okay, so if you have any question till here, please put forward those question in the comment box. I'll be happy to answer those things. If there's any question, anything, any part you didn't understood, happy to answer those stuff also. Okay, so I'll take a pause here. Thank you guys. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement, and enthusiasm is going to keep us moving forward. If you found this valuable, drop a comment, share it, and tell a friend who should join us.